Hello, my name is Karen Kennedy. I'm an electronic and computer engineering graduate from NUIT. Today I will be discussing the research carried out by Josephine Griffith and I, as detailed in the paper Using Markup Language to Differentiate Between Reliable and Unreliable News. I would like to thank you all for attending and hope you enjoy. The aim of this research was to develop a more accurate method to detect reliable and unreliable news articles without having to consider the article content itself. There were 3 steps taken in this research. 1, to analyze the data from the chosen data set to see if there were any significant differences between the tags used in unreliable or reliable sources. 2, to have run 5 classification algorithms on 2 separate data sets, NELA 2017 and Fake News Net, and then use performance metrics to compare the results. When the results were compared, we also compared the HTML tag frequencies method to other methods used to detect fake news. The first step taken in this research was to determine if there was a significant difference in the tags used by reliable and unreliable sources. This image shows the tags that had a stark difference between the reliable and unreliable frequencies. Note how the tags such as no script, style, and strong have far higher occurrences in reliable than unreliable sources, while tags such as UL, H3, and symbol had far higher frequencies in reliable sources than in unreliable sources. Again, moving on to further data analysis results, this image shows a comparison between tags used by reliable and unreliable sources. 132 of the tags that appeared in both types of sources. However, it also found that unreliable sources had 166 tags that were never used by reliable sources. This is 54% of all the tags that were obtained from the NELA 2017 dataset were only used in unreliable sources. Some examples of these tags are count, clip, path, HR, xscript, tspan, and menu. There were also 8 HTML tags that were used only in reliable articles. These tags include image, asset, inline, and custom span. Following the findings of the data analysis, classification algorithms were run on 1. HTML tags from articles in the NELA 2017 dataset and the Fake News Net dataset. 2. Content features from the NELA 2017 dataset were also extracted and passed into these same classification algorithms. This allowed for comparison to the HTML tag results. And 3. The HTML and content features were extracted from NELA 2017 dataset were also combined and passed into the classification algorithms. Here we see a table containing the results of the tenfold cross-validation. The results run on the NELA 2017 dataset show an average accuracy of around 97%. The authors of the paper and exploration of reliable news classification in Brazil and the US also made use of the NELA 2017 dataset and the LSVM algorithm, and found accuracies of around 72% when they used linguistic-based features. The classification on the fake news dataset achieved accuracies around 72%. Xu et al. Also used this dataset and acquired results varying from 49% to 64% when the content of the articles was used. Also, it should be noted that these results from the fake news dataset were closer to those using the smaller NELA 2017 dataset, which gave results of around 86%, than when we're comparing to a larger training dataset of the NELA 2017 dataset. Further investigation was also done into the HTML tag analysis of the NELA 2017 dataset. Confusion matrices of each algorithm run on the dataset are output and shown here. These were used to calculate the accuracies found on the right. These accuracies agree with results found in the tenfold cross-validation shown in the previous slide, i.e. there are around 97% accuracy for algorithms such as KNN and CART. Further performance measures carried out on the NELA 2017 dataset include learning curves and ROC curves. Both of these measurements further support the findings of the cross-validation results. In the learning curve, you can see how KNN and CART both have very high accuracies, and in the ROC curve, how they are nearly at right angles. A comparison was also completed between the results obtained from the HTML tag frequency analysis and the results found using the content and title analysis in the NELA 2017 dataset. These results show that the classifiers achieved around 60% average accuracy when using the content alone, while classification using HTML tags achieved around 97%. When the content and HTML tag features were combined, the resulting accuracies did not vary much from those found using HTML tags alone. The accuracy was around 96% was achieved when combining the content and the HTML tag features. It can be concluded that using the HTML tag frequency is a very viable option to use to detect fake news. It achieved far higher accuracies in its ability to classify news as reliable and unreliable than content features was able to achieve. Both were run using the same algorithms and the same dataset. Based on this research, the following conclusions were made. Due to the high accuracy of the results found, it can be said that there is a significant difference between how reliable and unreliable news design or code their websites. Because of the accuracy of the predictions found using HTML tags, it can be concluded that this new method of fake news detection is reliable and accurate. Also, the results were compared with other methods, and it can be said now that this project offers a promising approach to detect unreliable news articles without having to consider the content words of the articles. Finally, I would like to thank you all again for attending and hope you found this very informative.